Hey guys, it is time to wrap up our unit on regression and using regression models and using it to estimate data and all of that kind of stuff. So we are wrapping it up by talking about interpolating and extrapolating data. Interpolating and extrapolating are just fancy words for estimating, and if you're interpolating, that means that you're estimating between data points that are in your set. So if you have x between 0 and 10 and you're estimating for 7.5, that would be interpolating. Extrapolating means that you're estimating something outside of your data range. And so if you have between 0 and 10 and you're estimating for 52, then that's outside of the range of data points. So with that being said, interpolating is always going to be more reliable because you only know how the model behaves in the data set you're given. So if you're given the height of a kid between the ages of 1 and 7, and you're estimating that, and then you use that model to estimate the height of the person when they're 40 years old, you're going to get a really, really high estimate because you grow a lot faster and then it levels out. So interpolating is always going to be more reliable, and we're just going to look at a couple of different situations with that. So here's our first example, and what we're looking at is the population of Alberta, Canada between the year 2001 and 2005. So it wants us to write a linear regression equation using the year 2000 as year 0. So that means 2001 would be 1, 2002 would be 2, and so on. So I entered that in our calculator for us. To do that, you would go to Stat, Edit, and enter in your list. Before you calculate though, you're going to want to do two things. Always remember these. You're going to want to turn on your stat plot. So you're going to go to second, y equals, click enter on stat plot, and where it's flashing on, click enter again. You're also going to want to turn diagnostic on so that you get your R squared value. To do that, you're going to hit second and then catalog. To get to the D's quicker, you hit the inverse button that has the D above it. And then you scroll down until you get to diagnostic on. And y'all know it is going to take me a minute because the app lags. Okay, so there is diagnostic on. Once you get down there, you need to press enter. But you're not done yet. Whenever you get that message, you have to press enter one more time until it says done. And then you know it'll give you the R squared value. So the next thing it asked was for linear regression. So I'm going to go back to stat, but this time I'm going to come over to calc, and I want to calculate linear regression. There's two of these in here. For some reason, the second one just puts the constant in the front instead of after. It doesn't, I don't know, it just puts it in a different order. But I always choose the fourth option because that's how we typically do linear regression. And so we're going to click 4, or you could scroll down and click enter on number 4. And then for store regression equation, I want to put that in y1. So I'm going to go to variables, over to y variables, press enter on function, and then enter on y1. And then I'm going to calculate. And I won't go through all of these steps every single time, but I wanted to give a good overview. Now I'm going to go ahead and copy this into our notes. Okay, so I got my screenshot here. I'm going to write the regression equation. I do also want to point out that R squared value is 0.997, so this is a really good model between the year 2001 and 2005. And then if I want to actually write out the equation, then I would start with y equals, and my a value, it's ax plus b, so a is 48.87, and then times x plus b, which is 3012.23. So that's going to be my linear regression equation. Then it wants me to extrapolate, which again just means estimate the population of Alberta for 2019. So to do that, I'm just going to go back to my calculator here, and I'm going to go to second table, and I want to estimate for 19. You could go in and do table start as 19, or there's another way to do it where you just type in the number you want. I'm just going to scroll down this time because 19 is not too far away. And it gave us 19. There we go. The population it's telling us is 3940.8. And then that's in thousands, but that's how the rest of them are written too. So 3940.8 is the extrapolation we got. And then it tells you that the actual population of Alberta in 2019 was 4.307 million. So that would be like 4,307 with the way that the rest of them are written, since it's written weird in thousands here. So it wants to know, was the extrapolation a good prediction? So with that being 4,307 and that being 3,940, our estimation was pretty low, is how you would answer that, is that we got a low estimation or a low estimate. And so then the next slide just has a couple more questions about this. This one wants you to estimate the population in 1980. So that one's a little weird. What's going to happen is 1980, you're going to be going negative, and so it's 20 years before 2000, so you're going to be looking at negative 20. So for that one, I'm going to come to my calculator. This time I'm just going to change the table start, and I'm going to put in negative 20, and then go back to my table. And the estimation is 2034.8. So 2034.8. And it wants to know, was that a good estimate? And again, with the given estimate of 2191, it's a little bit low, but it's better than the other one was. But either way, we're just going to say it was a low estimate. So this starts our next example, and this one is talking about how the depth of the tide changes over time at a certain place in the water. And so the scientist is measuring it for 10 consecutive hours, and it gives the table there. And it wants us to write a cubic regression equation to model the data. So I already entered the data in the calculator, so I'm gonna go, I'll show you the table, is here. And then I'm gonna go to stat calc, and I need cubic regression. So that is number 6 right here. So I'm gonna press 6, and then I want to store my regression equation in y1, so vars, y vars, enter, enter, and then calculate. And here's my equation that I'm going to copy over. So I'm going to use my equation now to go ahead, or use that to go ahead and write my equation. So we would have y equals, a is 0.05 x cubed minus 0.93, so that's a 9, 0.93 x squared plus 3.74 x and plus 8.66. And then it wants you to extrapolate the depth 24 hours after the scientist started his observation. So let me come back to the calculator, and I'm going to redo my table start because it was negative 20, and I want it to be 24 now. So I'm going to go to second window and change that table start from negative 20 to 24. And then I want to go to my table. And we get 282.47. So if I come back here, then I'm going to say that the depth of the water was 282.47 feet. After only 24 hours when the original water depth was 9. So if you can imagine a change in water depth from 9 feet to 282 feet in 24 hours, would literally be like more than a tsunami. So, for is this a good estimate? No, it is definitely not a good estimate. And then it also wants to know what type of model may be better than cubic to represent the data. So I'm going to do a couple of things here. I know we've done questions where we discuss like how water depth changes over time. But first, in case I like didn't know off the top of my head, what I would want to do is I'm going to go and look at the scatter plot. So I have y equals already in there because it put my equation in there when I found it. And I'm going to hit zoom 9, so that's zoom stat, and it's going to show me what my equation looks like. So for this part, cubic is really good. But if you know anything about tides, you know it's going to go up, and then it's going to come down, and then it's going to go back up and back down, and so on. So that shape resembles a sine graph more. So for what other options may be better, we're going to say a trig graph. And for that, whenever you're talking about regression, it's called a sinusoidal model. And I honestly don't know if I pronounced that exactly right, but I'm pretty sure I spelled it right. So sinusoidal, yeah, it's a trig model. So then it wants me to write a regression equation using the new model. So I'm going to come back to my calculator and I'm going to go to stat calc again. And now this time I want trig. So in the calculator, that's going to be called sine reg because it's always going to write a sine equation for you instead of cosine. So C is sine reg, and I'm going to press enter on that. And then there's a couple of different things here, and I think that we discussed this in an earlier unit. For the period, there's mixed opinions on if you need to enter a value for that. From what I've observed, for the most part, it doesn't matter if you enter anything for period. It's going to come out as a very similar equation either way, and the calculator does a really good job of finding the period for you. So typically, I just skip period, unless it specifically tells you in the problem the period of the graph is this. This one does not, so I'm going to skip it. And for store regression equation, again, I'm just going to put that in y1. So I'm going to go ahead and get that in there and then hit calculate. And this is what it gives us for our sine regression model. So I'm going to copy that over to our slides as well. Okay, so now we're going to write out the equation. So you have y equals a times sine. So I'm going to have y equals, for a we have 4.03 times the sine of bx plus c. And notice that the b is not factored out right here, so you're not going to write it factored out, but that does cause it to be a little bit more tricky when you're trying to find the period, which we shouldn't have to do in this problem. But we have bx plus c, so it's 0.52x plus c is 0.03. And then plus d is 8.95. And then it wants you to estimate the depth again after 24 hours. So back to my calculator again, I'm just going to go back to the table because I've already got 24 as my table start, and we get 8.48 as our estimation after 24 hours. So 8.48 feet deep is what it's talking about. And it asks, is this a better estimate? So looking at the numbers that we have, it makes a lot more sense for 8.48 to fall in as the water depth than it did at 282 on the last slide. So yes, it is a better estimate. And the reason why, if you're talking logically, it would just be because tides are cyclic and the water is going to go in and out, and it's not going to go from being about 8 feet to about 282 feet in 24 hours. And now we are to our last example. So this one is talking about a study done to compare the speed with the mileage, which is the number of miles per gallon that you're getting in a car. And the results are shown in that table. So the first thing it wants you to do is write a quadratic regression equation to model the data. So again, I've got the data in for us, and I'm just going to come and I'll show you that I've got the data in. And then I'm going to go to Stat Calc, and this one it said quadratic. So that's quadrag, which is at number 5. So I'm going to click 5 and then go down to Store Regression Equation. And I'm going to store that in Y1. So I'm going to hit vars, over to Y vars, and hit enter twice. And I'm going to calculate. And I get this as my quadratic regression equation. I'm not going to copy it over this time because there's not a lot of room on this slide, but it would be y equals negative 0.008x squared plus 0.75x plus 13.79. And I will go ahead and write that out for us. So I have that, and then it wants me to extrapolate the y-intercept of the data. So first I'm just going to come over here and hit zoom 9 to see what it gives me when I have zoom stat in there. And it shows me this quadratic graph that we made with the data, but it doesn't really show me the y-intercept. So I could change the graph. I'm just going to go to the table though. For the y-intercept, that's going to be where x equals 0. So I'm just going to come to table set and change table start back to 0, which is what I typically like it on anyway. And then I'm going to hit second graph to go to my table. And at x equals 0, y equals 13.795. So I'm going to write out 13.795. And this is miles per gallon. So the next question, well, it says, does this make sense in the context? So that means your speed is 0, but you're getting 13.795 miles per gallon. So if you think about it, when your speed is 0, that means your car isn't moving, so you're not using any gas, so it doesn't make sense to be getting any mileage. So I'm just going to say, no, it does not make sense. And then that would be the explanation for why it doesn't make sense. So then it wants you to find the speed where you're going to get the best gas mileage, and the best means the most miles per gallon. So I'm going to come back, maybe, there we go. And I already have my graph in there, and I want to find the max. I want the most gas mileage. So I'm going to hit second, calc, which is at trace, and then for maximum, that's number 4. And it wants me to go on the left-hand side of the maximum, which is somewhere over here, and then on the right-hand side of the maximum. So I'm just going to scroll over the top, and that's far enough, so I'm going to press enter over here, and then ignore where it says guess and just press enter again, and it'll give you the maximum, and this is where x equals 44.97 is going to be the speed you'd be going to get the best gas mileage is 44.97 miles per hour. And then it wants me to extrapolate the mileage if we're driving 110 miles per hour, which is obviously not a recommendation, but we're going to go ahead and extrapolate that. So coming back to this, I'm again just going to change my table so that I can see where it is. So table start, I'm going to put at 110 and press second graph to get to my table. And it tells me I would be getting negative 4.6 miles per gallon. So I'm going to come back in and say the mileage would be negative 4.6 miles per gallon. And then, is that a good estimate? So, if you're getting negative 4.6 miles per gallon, that means that as you're driving, your car is filling up with gas. So no, obviously that is not a good estimate. So that one was just an example of how extrapolating can be not the best method sometimes because you're looking at numbers that like are not necessarily going to be in your data range, or it just like doesn't make sense to estimate that. So like yeah, you can get how many miles per gallon you would get if you were going 0 miles an hour. So if your car isn't moving, it'll give you a number, but that doesn't mean that you should use that number. So this lesson is more just about like thinking logically as you're finding these regression equations and knowing what to look for and which models to use and which numbers to trust. So hopefully that makes a little bit of sense and can help you guys think through some of these problems.